Hi, Mick McQuaid here with part 4 of our continuing series on chapter 1 of our textbook, R for Data Science. And in this part, I'd like to talk a little bit about stats or statistical transformations. Stats is the ggplot2 parlance, and they are statistical transformations. So in this section, this is actually a very brief section. It's mostly exercises. We're just going to do a few things here. First, we're going to look at a bar chart and its default stat. Oops, there's my cursor. So the chapter starts out, or the section I should say, starts out talking about this geom bar, and its default stat is count. So what we've specified along the x-axis here is the cut of the diamonds, which can fall into one of these 5 groups. And the y-axis is count, which is the default stat. So what's happened here, and we can take a look at the textbook here. What's happened here is that geom bar starts with the data set, does a transformation of the data set using count, which returns this much smaller data frame, and then it does a graphic based on this much smaller data frame. So this is the layered grammar of graphics in action here. Now we can find out what that default stat was. If I didn't happen to just mention it, we could look at the help for it, and we would see that it says here stat equals count. So that's the default stat for geom bar. And as it turns out that there is a stat count, so we can use the stat with its default geom the same way that we can use a geom with its default stat. So I'm going to give basically the same code here as here, except instead of geom bar, I'm saying stat count. And the result, as you can see, is exactly the same thing. Now, we might not always want to use the default. We might want to use something different. So we're going to create a table here. This is an assignment operator right here. We're going to assign the output of this. This is a row-wise tibble. It's called a tribble. It's a row-wise tibble, which is a kind of data frame. Or it is a data frame. I shouldn't say it's a kind of data. It's just a data frame. This is just a row-wise way of specifying it. So we have this as a row. Instead of specifying it column by column, we're specifying row by row. Okay, and we can use a different stat than the default here. We're going to use stat identity with geom bar, and it's going to give us a different output. Although it looks much the same, notice along here, along the x-axis, we have geom bar. Along the y-axis, we have whatever was in column B. So this is just the name of the column. This is what's in that column that matches this. So this is a different stat than the default. We can also use proportions with geom bar. And here we see a proportion instead of a count on the y-axis. Now we can use a different stat here. This is going to be a, what is this? Oh, this is going to be a different kind of graphic. So this is interesting. So stat summary has a different default. So this is called a point range. And this is a different default, and we can find that out by inquiring of stat summary what its default geom is. And we'll see that the default geom for this is called point range. So that's the type of geom that we're looking at here. Is point range, and we can see that also in the geom point range here in the ggplot2 cheat sheet. Okay, and then the next thing to do are the exercises. And the first exercise is to look at stat summary. So why are we looking at stat summary? We want to know, this is just what we just looked at. What is the default geom associated with stat summary? How could we rewrite the previous plot to use that geom function instead of the stat function? Well, it's the stat summary function. So here's rewriting it. Well, is this really it? See, I can do okay, so here's just the summary. So this does not have y min and y max. This is just the point estimate and some kind of error estimate. This is the this is not really the default. I think the default is stat identity. Did we look here at what the default was? Stat summary is point range. So how could we do this? So I think what I need is a different thing, and I for some reason I couldn't seem to grasp what they were asking. So I looked at the online solutions from Jeffrey Arnold, and basically what his take on it is that it's the same as this, rewriting it basically to be the same thing as this. So, but rewriting it with geom point range instead of stats summary. So let's run that. We should get the same result that we got from stat summary above. Okay, question. So that's how we would rewrite the previous plot to use that. Oh, to use that geom function instead of the stat function. Okay, I get it now. I'm a little slow today. Okay, what does geom call do? How is it different from geom bar? Well, we can just look at the help for geom call, and it's going to give us actually the help for geom bar, and it's going to say there are two types of bar charts. Geom bar makes the height of the bar proportional to the number of cases in each group. Geom call uses stat identity, so it leaves the data as it is. If you want the heights of the bars to represent values in the data, use geom call instead. Most geoms and stats come in pairs that are almost always used in concert. Read through the documentation and make a list of all the pairs. What do they have in common? Okay, well, instead of doing that, I just read the ggplot2 cheat sheet, which has all the geoms on one side and all the stats on the other side. And they have plenty of things in common. One thing that's very obvious from the cheat sheet is that they depend on the number of variables involved. And this corresponds to the standard constructions in the grammar of graphics. Okay, what variables does stat smooth compute? Well, let's find out, shall we? Computed variables are y predicted value, y min, y max, and standard error. What parameters control its behavior? So the parameters that control its behavior are somewhere near the top here. Stat smooth. So these are the parameters to stat smooth. Okay, number 5, in our proportion bar chart, we needed to set group equals 1. Why? In other words, what is the problem with these two graphs? So let's take a look at these. The problem is that they use the entire sample of x values, as if you said group equals cut. So I'm going to do them with group equals cut explicitly, but if I eliminate this, I'm going to get exactly the same result. So what's happened here is that it's used all the x values to compute this. So the proportion of x values that are x values is 1. And the same thing is going to be true of this one. The proportion is equal to 1. It's 100%. So if I instead say group equals 1 here, oops, group equals 1 here and group equals 1 here, I get correct proportions. These are now the proportions that belong to the individual value of the cut. Okay, and is that it? Yeah, that's it for statistical transformations, stats, to put it briefly. And next we're going to talk about position adjustments, but we'll do that in a separate video. So that's the end of this video. Thanks for your attention.